Hi everyone, okay, so today I have decided to do a wee video here on a project that I created during lockdown. So this project was previously uploaded to my YouTube channel. It is a very sophisticated project, a really interesting project. Basically what it does is it mimics finger joint movement and it measures the sensor technologies to a high precision. Okay, so this is my sensor measurement station. Well, it's for my data glove. It's designed to monitor my data glove when I have the data glove complete. So, I have named it Electronically Controlled Sensor Measurement System, so XMIS for short. So this is in one of my journals that I've published for my research. It's advanced. There's nothing like it out there. It's all my idea. I've designed it at home here and I've built it at home. So what we have here is two high precision bearings. We have a stepper motor. We have an encoder. We have a Hall effect sensor here. We have an IMU digital sensor here. We have two analog sensors and they are enclosed in two capsules. So these capsules are designed to follow the way the sensors would be placed inside the pockets of a data glove. So now moving on to the microcontrollers. So one microcontroller is set to monitor the sensors and the back microcontroller is set to drive the stepper motor. This stepper motor can move from hyperextension, well, it can move this arm from hyperextension right around to fully flexion, which is 130 degrees. So there's a Hohmann cycle here, and when this arm comes up, it goes past the zero. So when this arm is level to this red part of the platform, it goes past it and it comes down slowly to find true zero. I am going to do a wee experiment here and I'm going to show this a wee demonstration. But before that, there's two switches here. One of them's not used at the minute. One of them's to start the cycle, to start the process. So what I can do here is I can upload programs to this that I've created. I have a repeatability program. I have a accuracy program, and I also have programs to mimic the symptoms of rheumatoid arthritis. So basically, I can move this arm slowly, or I can move it rapidly, fast. So I'll demonstrate this now, and then if I've missed anything, I will just go over it again. Okay, so if I wanted to move this arm in very small increments, I can move it from this point to this point in around, I think it's 40,000 steps or 45,000 steps. So it's quite minute, it's quite small. Okay, so a close up of the mechanism here. So what I have here is two, I think it's 40mm, 35mm countersunk bolts, 6mm. They are welded together with the TIG welder. They are done to precision. So as you can see, they look quite true to each other. Well, very true. You don't see any discrepancies. They're perfect. I also have another countersunk screw which is welded directly to this one, and we have a magnet attached to here, and we also have another encoder in here, and we have this little coupler that connects another M6 countersunk screw to the stepper motor. So I'll just flip it over the body here. Hopefully the camera stays focused. So there we have a little screw that attaches the aluminium arm to the stainless tab that's welded directly to these bolts. So this aluminium arm, you can see it has holes and everything in it. So that's to keep the arm as light as possible, so it doesn't interfere within this range. So I've obviously messed up the cycle here now. So when I reset the board here at the back, so this is the board driving the stepper motor. What happens is it's ready to do the Hohmann cycle. So I'll start this here now. So I have the power supply on. So when I hit the switch now, it finds true zero to within 100th of a degree. So it's really, really accurate. So this traffic light, this signal that I have set is that's done on the program just to say that the platform is ready to go. So when I hit this now again, it goes through the stages. Well, sorry, hold on. There we go. It goes through the stages of moving the arm and also monitoring the sensor technologies. So this one on the end here is AMU, so that's the sensor technologies that you would get on an aircraft. So this program uploaded to the station here now is a repeatability program. So what it's doing, it's going to 5 degrees back to 0, 5 degrees back to 0, 5 times, I think it's 5 times. And then it moves on and does another repeatability test at, say, 15 degrees. So there we go now, say it's doing 15 degrees now. It does a homing cycle between each repeatability test. You will see that now. Homing cycle, found through 0, and away it goes again. So the data now, if I plug a cable into this point and run it to my computer, I can stream the data out of the AMU, the Hall effect, the platform, the fiber optic sensor here, and also the flex band sensor simultaneously. So all data can be streamed alongside each other. So what I have found is obviously the digital sensors are far more advanced, far more precise. The Hall effect technology and the AMU. The flex band sensor is, and the fiber optic sensor is quite not as accurate. So there's a lot of spikiness coming from the fiber optic, and this here is the same, but it's very non-linear. So I think it's moving to around 45 degrees now. So what I plan to do here is create a dummy finger and place my smart glove onto the platform. And then I will upload a program that mimics like joint stiffness, if that makes sense. So what I'm going to do here is just stop it. And just do a wee homing cycle again. So it comes down a wee bit and then it goes past, sorry, the switch. So the traffic light's now signaling that the platform's ready to go again. And away it goes. Green light saying the platform's going through the program. So that's it. Okay, so the platform now is coming right around past 90 degrees. Every time you hear the beep is when the platform takes a reading from the 4 sensor technologies. One final thing here to discuss. We have this ferrite clamp which mitigates any EMI signals from entering the system. We don't want that. So you can see the capsule's working very well there. So we're right round now to around 125 degrees, and I will stop it there. Okay, so that's it, complete this short video demonstration. One thing I want to point out there is the platform has its own output. So the platform is validated to 100th of a degree, so it's very, very accurate. Another thing I want to point out, I don't even remember now what it was, but yeah, I forget. But if you want to see more on this project, do look up my YouTube channel. I will also put the 2 links to my journal in the description here if you can on TikTok. TikTok's new to me, I haven't used it before much, but I will start introducing or showing or demonstrating all my unique projects that I have built over the years. And now my most recent project, my smart glove for monitoring the hand joints for rheumatoid arthritis. Bye bye.